Hey everybody, kind of a long time no see. This month I was pretty busy with some family issues, so I had to postpone a series of videos that I actually already planned. But finally I found some time and we can now go on. So we're going to go on with the jit.gen series. We're actually going to use the Gen programming language, let's say inside jit.gl.pix instead of inside jit.gen, and we are going to use the Codebox for the first time in the series. So this is like a series inside the series, and it's going to be focused on working with images, specifically with textures, because the best way of working with images in Max is almost always with textures. And that's why we're going to use textures and jit.gl.pix and a jit.gl video playing to display the final result on our window. So in this first video of this mini series, we're going to see how to fit an image to the width or the height of our window. So for example, if we just connect the video plane to the jit.gl texture, the image is going to be resized according to the size of the window. So it's going to fill the whole window and the proportions are going to be lost. But if we use this little algorithm, for example, with 0 we are going to fit to the width, this means that the proportions of the images are always going to be correct and the image is always going to be to cover all the width of the window. So if the image is actually bigger than the size of the actual window, this means that a bit of the image will be cut. Okay, and then we got fit to height, in which the image always sticks to the height of the window. So this means that if the image is bigger than the actual window, we will cut the image on the width, so on the x-axis. And we're going to do this using the code box. Okay, so let's go and let's start from scratch. Okay, so let's get our world plus camera. We actually don't need the camera since we are going to work only in 2 dimensions with images, so away with that. We need though the get attribute size object attached to the jit world, because we're going to need the size of the window. And great. Now in order to load the images from our hard disk, I'm going to fill a U menu. We're going to use a U menu with the auto populate attribute set to 1. So sorry, this was a bit fast, so I just gave the auto populate 1 attribute to this object, which by the way you can also find inside the inspector. If you want to give it the auto populate, you just set the box here to 1. Cool. So what happens now? If we give it the path of a folder that contains some images, this object is going to populate with the name of those images and is going to output the path to those images. So it's really great, it's really what we want. So let's use, in order to populate the object, let's use the drop file object, which will give us the address inside our computer of the folder or the file that we are going to use to populate the U menu. So we have to just say prefix, we have to say prepend prefix. So this is a command for the U menu that means populate the U menu with the stuff that is inside this folder. So let's actually get a folder, for example this one, let's put it here, cool. So as you can see, I just dropped the folder inside the drop file object. I got the address of this folder as a symbol, and then this goes inside the prepend prefix, which then goes to fill the U menu object. As you can see, it's not only images inside, there is also another folder. So also the other folder is actually contained inside here, but we cannot use it because it's just a folder. So I'm going to limit myself to use those image files. So for example, you can see when I choose one image, just gives to home, desktop, Jasper, patch, and images, and then name of the image. So this is exactly what we need, for example, to read an image inside the texture. So if we create a jit.gl texture object, give it game, and say prepend read to that, we're going to read the image or whatever file it is, but preferably an image contained at this address. So let's see if this is actually working. Let's connect the GP window, let's select an image, then we actually need to bang it. Cool! So it read the image that we wanted. Great. Let's actually connect the metro to this object, since we're anyway going to work on this image at every frame. So we can connect the metro here, and this will give us continuously the texture in output. As you can see, the GGL texture is continuously outputting the texture message. In case you don't remember what's the difference between a matrix and a texture, you can check my video CPU versus GPU, which kind of explains that. And this you can find either on my YouTube channel, you can access it from my website, federicofederao.com, in which I have all my video tutorials organized by categories. So I just want to make this known in case this was not known. Great. So we are going to use textures. As you can see, this gives us the GGL texture. So if we connect this to a GGL video plane with transform reset 2, so it's going to cover the whole screen. And you can see that we have basically the image squashed on our video plane. So the whole image, it covers the whole rendering window. And it doesn't take any account of the proportions. We can actually set the preserve aspect value to 1, but this is only going to work for the video plane, so it's not actually affecting the texture itself, it's only working on the video plane, and it only sticks to the width or the height according to the actual size of the window. So still useful if you just need to display a video or an image maintaining the proper proportions, this is going to work. But if you want to work more on texture or mix more textures together, then you may want to go on with this video and check how you can set the proportions of the image using texture coordinates and not using the preserve aspect attribute of the GGL video plane. So still useful, but this is not what we are going to use in this video. So in this video we're actually going to preserve the aspect ratio with the fit to width or fit to height using jit.gl.pix object and texture coordinates. So let's connect this here and let's get inside jit.gl.pix. Jit.gl.pix is exactly like jit.gen, but it works with textures and only works with 4 planes texture. So the textures are always considered to be 4 planes, and the dimensions are mostly going to be 2-dimensional or 1-dimensional, but never 3-dimensional, and so on. As far as I know, actually, I think this is still not possible. You need a shader for that, but so we're going to anyway work with 2-dimensional textures. So cool. As we said in the beginning, we're going to use the Codebox object, which basically allows us to work with the Gen programming language directly using this kind of written code inside the Gen environment, which is it's mostly pretty practical for a lot of reasons. So we could do the same things also using objects, but it's kind of more tidy up and more neat to actually just do these in the code. So how does it work? If we say out1 equal in1, and you can see that it's actually just outputting the image. If we say, for example, out1 equal in1 plus 0.5 is going to sum 0.5 to the wall, to every pixel in this image. What we want to do actually is to create a couple of functions. So let's create a function called fit to width. Now, when using Gen, you actually don't need to declare type of stuff. So we don't need to say that this is a function or to say what it returns, like integer. No, we just say the name of the function, and then it will understand that this is a function because we give it some parentheses. So we actually need the window dimension inside here and the coordinates that actually the Gen environment provides us, which are the norm. But we are going just to pass them instead of redeclaring them inside every function. Cool, then we close the function. As you can see, it gives us an error because there is no body to this function. So what we're going to return from this function are actually new coordinates that we can then use to make the image fit to the width or to the height. So first of all, we need a parameter with the window dimension. So let's create a param. We have to declare it after the functions because the function must be the first thing declared inside the Gen. So let's call it window dim and let's give it a value, for example, of full HD. Cool. Let's do, for example, like that. Let's write return chords. Okay, great. Then here, consider that our final output, it's equal to, let's use nearest as a sample. And let's actually declare the coordinates explicitly. So new coords equal fit to width, and then we get to give it the window dimension as an attribute to this function, and norm, which are the coordinates. And then we can say nearest, final output is the nearest sample of input 1 using the new coords. Okay, so output 1 is going to be final output. Okay, great, nothing changed because we are simply using exactly the normalized coordinates to sample this image, so nothing happens. But if we multiply it, for example, by 2, then we get the image 4 times because we are sampling it at double the coordinates. Okay, great, so we're going to do something a bit more interesting with this function. So this is going to feed the image to the width of the window. So what we need to do, so we need to find the relation that the epsilon dimension has to the x dimension. So let's do like this, epsilon ratio, it's equal to actually the dimension dot x of this texture divided by the dimension dot x. So the dimension dot epsilon of this texture divided by the dimension dot epsilon. And this gives us the epsilon ratio. So for example, if we get an image that is 1920 by 1080, if we want to find the epsilon ratio, we actually need to do 1080 divided 1920, and this is going to be the epsilon ratio. So this is going to mean that the epsilon dimension is going to be 0.56 times the size of the x dimension. Cool, so we need to know that because if we want to fit the image to the width of the P window, then we actually need to know for what we're going to multiply the epsilon coordinates. So it's pretty simple, we just do something like this. Let's call it chords epsilon, it's equal to chords.epsilon, so the chords that we input as an argument to this function multiplied by the epsilon ratio. So great, if we now return a vector 2 using chords.x and our new chords epsilon, we get an error because okay, I actually found the error, which is that we don't need to use the dimension of the texture. By the way, I also wrote window and not window, so window with a W here at the end. We actually need to use the dimensions of the window to get the ratio, because we want to get the actual ratio, epsilon ratio of the window. So cool, so if we do this, now you can see that the image sticks to the width of the window, but why it's not behaving properly? Because we didn't send the new window size to the jit.gl.pix game. So let's do like that, let's send window size here from the get@object, let's receive it here, let's prepend window dim, and we should be good. So let's connect this here. Exactly. So as you can see now, in the original example, the image is always sticking to the width of the window and it's always maintaining the correct proportions. Now, as you can see, if I make the height of the window greater than the size of the image sticking to the width, then it's going to repeat the image several times. So this could be something that we don't want. So let's actually do something like that. So let's get the difference, let's get kind of the black band lines on top and at the bottom. So in order to do that, we need to find the difference between the wall run of the coordinates, which goes from 0 to 1, and the actual ratio that we found from the window. So if we do something like that, like diff equal to epsilon ratio minus 1.0, so okay, we didn't use it yet. So this gives us basically the difference between the actual ratio and the wall value of 1, which is going to be the wall. So the coordinates in the window are going to go from 0 to 1 to the end of the window, so the coordinates of the texture, because the texture is going to anyway to fill the wall window. So then we need to divide this by 2.0. So let's create a variable, let's call it edge, and assign it to 1. And then let's say if chords epsilon is less than 0, Then edge is equal to 0. And if chords epsilon is greater or equal to 1, because 1 is also a value that we reach with the coordinates, then the edge is also equal to 0. So we want to multiply the edge to our image in order to get these black bands on top or bottom. So when the coordinate is going to be less than 0, which is never the case in this case, this is going to be black. And when the coordinates are going to be greater than 1, which is the case, for example, here, so the coordinates multiplied by the ratio you have to think, then this should going to be black. So let's do like this. Let's return the coordinates and let's return also the edge. So in general, we can return multiple values from the same function just by doing this. So in order to assign then those return values, we have to write also another variable here after the new coordinates. So the first variable returned is going to be the new coordinates, and the second value is going to be assigned to edge. So then let's multiply this by edge. Great. So you can see that we deleted this. We have now a black band here where the coordinates multiplied by the ratio are greater than 1. So what we need to do now is actually subtract to the epsilon coordinates. So chords epsilon. We need to subtract to that our diff. Exactly, because then we just move everything basically down of half the difference between the coordinates multiplied by the ratio and 1, which is the whole range of the coordinates. So, cool. As you can see, now it works, as I showed you in the beginning of this video. Good, so this was the fit to width function. Let's actually create also the fit to height. Let me copy the whole function. Passed it here, and instead of calling it fit to width, let's call it fit to height. So we still need the window dimension and the coordinates, and instead of getting the epsilon ratio, now we need the x ratio of the window. So window dimension x divided by window dimension dot epsilon. Coordinates is, let's call it chords x, because this time we don't need to multiply the epsilon coordinates, because the epsilon coordinates are always going to go to from 0 to 1, but in this case the x coordinates are going to be multiplied. Like before, when fit to width, the x coordinates were always going to 0 to 1, and the epsilon coordinates were changing in order to maintain the correct proportions. But now we want to multiply actually the x coordinates and keep the epsilon coordinates going from 0 to 1 in order to maintain the correct proportions. So coordinate x norm dot x multiply this time by the x ratio. Great difference is just going to be the x ratio minus 1 divided by 2. That's going to be the same. Edge is going to be the same. Coordinate x, same trick of subtracting the difference. Edge is the same. Now we just need to write here chords x and here chords dot epsilon. Great. Okay, let's create a new parameter here and say param fit 2, and then we got 0, which means height, and or width, and 1 that means height. So let's do something like that. If fit 2 it's equal to 0, then do that. Let's actually create these two variables outside of the if. Exactly. Oh, let's maybe assign it also like to norm, and edge, let's assign it to 1. Exactly. Then if fit to 0, if fit 2 is equal to 0, then do the fit to width. Else, if let's specify it, if fit 2 it's equal to 1, do it with fit to height. And we got an error because we still kept chords epsilon. Here it should actually be chords x. Okay, cool. Great, this seems to be working. Okay, so let's actually try with a message. So fit to $1. Let's actually create like a radio group of size actually 2. And so 0 is going to be fit to width, and 1 is going to be fit to height. Okay, so let's try fit to height. Cool. It works. Great, so it's fitting the image. To always cover the wall height of the window, and in case cut the x-axis in order to maintain the correct proportions. So, great. And of course, while I was editing this video, I found a bug with our little program, because as it is now, it's actually always going to give us a square image, which is not at all respecting the proportions of the original image. Like, this should be a full HD image, so 16:9, and this is actually not what this is. This is like a 1:1 proportion, so it's always giving us a square proportion because we are never using the actual dimensions of the image in our algorithm, which we definitely need if we need to keep the proportions correct for the image. Okay, so what we need to do is to add another argument to our let's actually do it from scratch. So to add another argument to our function here called image_dim, and then here when we call the function, we give it the dim as an argument, because we actually cannot access the dimensions of the image here before in a function declaration at the beginning. So this is a bit cumbersome, but we need to input in the function as an argument. That's why we need to specify it here. So this is going to be the dimension of the texture. So then we need to find the ratio of the image. So this is the ratio of the window, so epsilon ratio window. Then we need the epsilon ratio image, which is going to be image_dim.epsilon divided image_dim.x. So we find the actual proportions of the image, so how many times the epsilon dimension fixed inside the x dimension. So then let's create a variable called epsilon ratio, which I actually did it already here. And let's say epsilon ratio is divided equal to epsilon ratio of the image. Sure, we need to actually say that epsilon ratio is equal to epsilon ratio window divided by epsilon ratio image. Right. So the epsilon ratio of the window we just used to kind of get the coordinates from 0 to 1 inside the actual window. So this we get to kind of maintain like square proportions inside our window. So even if our window is not square, we keep then square proportions. And then we need to multiply our epsilon square coordinates with the actual ratio of the image. So we need to actually divide the square coordinates with the epsilon ratio of the image. And in this case, we get the correct proportions, because this is a full HD image 16:9, and it looks correct. As you can see, it has much more width than height. Perfect. So the same thing goes with the fit to height. I'm not going to do it myself, but it's actually super easy. You just have to do the same thing we did with the fit to width, and you just need to invert the image dimension.x and image dimension.epsilon instead of the other way around. So yeah, this actually makes our code work correctly. As you can see, it keeps the correct proportions. So let's go on with the end of the video. This was it for this video. We are going to work a lot more with texture in the next videos. We're going to see how to zoom in, how to especially cut textures in order to display them as we want, and especially in order to understand also how texture coordinates work. So I hope this was clear enough, and thank you very much for following. For every question, I'm here available here or on my Patreon on the Discord channel. So the patch from this video is going to be available in 1 week for everybody, and it's going to be available right now for my patrons. So thank you again very much for following, and see you soon. Ciao.